In this lesson, we're going to talk about how to simplify complex rational expressions. So before we start, we need to talk about two general definitions. The first definition is of a mixed number. Now this is something that you've used before. So a mixed number is a number that contains the sum of an integer and a fraction. So for example, 2.5. Well, because a 2 is the integer and the fraction is a half. Now we know that 2.5 is really the same as 2 plus a half. And if I were to add those together, I would have to get a common denominator. So 2.5 would be the same as 5 halves. The other definition we need to talk about is the definition of a mixed expression. A mixed expression is an expression that contains the sum of a monomial and a rational expression. For example, 3 plus x plus 2 over x minus 3. And we're going to use both of these types of numbers today, mixed numbers and mixed expressions, when we are simplifying these complex rational expressions. So if we look at number 1, in number 1, we have a mixed expression. So I'm going to first take my whole number and put it over 1. Then, just like we did when we were adding and subtracting, I want to get a common denominator. So in this case, my common denominator is going to be n minus 1. So I'm going to multiply that on the top and the bottom of the 9 over 1. And when I do that, I'll get 9n minus 9 over n minus 1 minus n plus 4 over n minus 1. Now I want to combine like terms, and I'm going to change this to a plus and change those to minus. So when I combine these, I combine them correctly. So I'm going to have 8n minus 13 all over n minus 1. Now I want to check to see if the 8n minus 13 is factorable, but in this case it's not. So this would be my final answer. Go ahead and try example 2. Let me know what you get and check it when you are done. Pause the video now. So for example 2, I got the common denominator of x plus 7, and then I combined like terms, and I got 4x plus 26 over x plus 7. Or I could have wrote it as 2 times 2x plus 13, because I factored out the GCF of 2. Now either way is fine. Typically I'll factor out a GCF if in hopes of it'll simplify with the denominator, but in this case it did not. So I can leave it as either answer is completely fine. All right, let's move on to some more complex fractions. So we look at example 3. There's actually a tiny error in how example 3 is laid out. So right now I have a fraction in the numerator divided by a fraction in the denominator. This line right here should be the darkest one because that's my main division line. So if we reflect kind of back what we talked about in your stuff from middle school, when I have a fraction divided by another fraction, I'm going to stay change flip. Or I'm going to multiply the first fraction, which is xyz over x squared. I'm going to multiply that by the reciprocal of the second fraction. Once I change this into a multiplication problem, it looks really similar to the types of problems we did 2 days ago. So the first thing I'm going to do is combine like terms on the top and the bottom. So I'm going to have x to the 5th yz over x to y 5z. And this will simplify to x3 over y4. Because my z's will divide to 1. I have 1y on top and 5y on the bottom, so that gives me 4 y's on the bottom. I have 5 x's on top and 2 x's on the bottom, so that leaves me with 3 x's on top. Now, for example 4, we're going to use the same method, but I'm going to have to do a little bit of factoring. So I have my top fraction divided by, well, the bottom, which I can make a fraction because I can always put anything over 1. And again, my main dividing line is right there. So I'm going to do my first fraction, which is y squared minus 1 over y squared plus 3y minus 4. And I'm going to multiply that by the reciprocal of my second fraction, which would be 1 over y plus 1. Now, I need to do some factoring. So I'm going to factor this first fraction. My numerator is a difference of squares, so that'll factor into y plus 1, y minus 1. My denominator is a trinomial, so what multiplies to negative 4 and adds to 3 would be y plus 4, y minus 1. And it's still multiplied by 1 over y plus 1. Now I need to simplify. So my y plus, or my y minus 1s will simplify, as well as my y plus 1s, which means my final answer will be 1 over y plus 4. So the difficult part about a lot of complex fractions is simply deciphering how to rewrite it as a multiplication problem. Once we rewrite it as a multiplication problem, it's very similar to the problems we've been doing. All right, so if we look at example 5, again, I have this first fraction, and again, my division bar is kind of in the wrong spot. So this is my numerator. Let me rewrite that. This m plus 5 over m is my numerator. And this m plus 7 over m is actually my denominator. My main division line should actually be right here. So my numerator is m plus 5 over m. And before I do anything, I need to have a common denominator within my numerator. So the first thing I'm going to do is do that. So I'm going to put my first term over m, over 1, and then my common denominator is going to be m. So I'm going to multiply by m on the top and the bottom. So then my numerator will become m squared plus 5 all over m. Now again, this is just the numerator. My denominator is what I outlined in blue over here, m plus 7 over m. So now I'm going to take that denominator and I'm going to multiply by its reciprocal. Because when we do division of fractions, we're always multiplying by the reciprocal. Stay, change, flip. So now that I'm multiplying by the reciprocal, I can simplify. Well, this m will divide with this m. Now, m squared plus 5 doesn't factor, and m plus 7 doesn't factor, and they also don't simplify. So my final answer is m squared plus 5 over m plus 7. Go ahead and give example 6 a try. Remember, I'll give you a little hint here. My numerator is the 3 plus 6 over x, and my denominator is the x plus 2 over 4. So go ahead and simplify that, play the video when you're ready, and we'll go over it. All right, so in example 6, I took my numerator and I got a common denominator within the numerator. So my common denominator was x, so once I got the common denominator, I had 3x plus 6 all over x. Then I multiplied by the reciprocal of my denominator, which was 4 over x plus 2. Now at first, it doesn't seem like anything will simplify, but then I realized I can actually factor 3x plus 6 into 3 times x plus 2. So then my x plus 2's will simplify, leaving me with 3 times 4 and just an x. So 12 over x is my final answer. All right, let's continue this idea of getting a common denominator within the numerator and within the denominator in examples 8 and 9. So if I look at example 8, my numerator is the 4 plus 12 over 2x minus 3. My denominator is the 5 plus 15 over 2x plus 3. So first I'm going to just work on the numerator. And again, I always want to get a common denominator within each of the numerator and denominator. So if I'm working on the numerator, I'm going to get a common denominator by putting the 4 over 1. And then I'm going to multiply by 2x minus 3 on the top and the bottom. And what that'll give me is 8x minus 12 plus 12. So now my numerator will become 8x over 2x minus 3. Now I want to work on the denominator. So this time I had to get a common denominator within the denominator as well. So my denominator was 5 plus 15 over 2x minus 3. So I'm going to put that 5 over 1, and I'm going to do the same thing I did with the numerator. I'm going to multiply the top and the bottom by 2x minus 3. 2x minus 3. And so I'll have 10x minus 15 all over 2x minus 3 plus 15 over 2x minus 3, which will give me 10x over 2x minus 3. So now I can take my numerator and multiply it by the reciprocal of my denominator. And when I do that, my 2x minus 3's will divide, and I will be left with 8x over 10x, which will simplify to 4/5. So now looking at example 9, it's going to be similar to example 8, where I have a numerator and I have a denominator, and I'm going to need to get a common denominator within both. So if I'm looking at my numerator, I have 5 over x minus 3 minus 2 over x. So in these cases, these denominators don't have anything in common. So I'm just going to flip-flop my denominators. So my common denominator is going to end up being x times x minus 3. So in order to get that common denominator, I need to multiply my first fraction by x over x, and my second fraction by x minus 3, x minus 3. And when I do that, I'll get 5x minus 2x minus 6. So when I combine those, my new numerator will be 3x plus 6 all over x times x minus 3. Okay, now I'm going to work on the denominator. So my denominator was 2 over x minus 3 plus 1 over x. So again, I want to get a common denominator. And my common denominator, again, is just going to be x times x minus 3. So to achieve that, I need to multiply my first fraction by x over x, and my second fraction by x minus 3 over x minus 3. And when I do that, I will get 2x over x times x minus 3 plus x minus 3 over x times x minus 3, which will combine to 3x minus 3 all over x times x minus 3. So now I'm going to take my numerator, which was 3x plus 6 over x times x minus 3, and multiply it by the reciprocal of my denominator. And right away I can see that my x and x minus 3's, those will simplify because I have those both on the top and the bottom. Which means I will be left with 3x plus 6 over 3x minus 3. Well, those can both be factored. So if I factor the numerator, I'll get 3 times x plus 2. And if I factor the denominator, I'll get 3 times x minus 1. Well, then my 3's actually divide. So my final answer is going to be x plus 2 over x minus 1. We are actually going to skip example 10. But if you wanted to do it, you'd have to factor each of these denominators, get a common denominator within each, and then stay, change, flip. If you'd like to try 10, you may, and then you can look at the work on the notes answer key.